All right, so for the fifth lesson, we are going to be talking about the standard form of a line. One thing that I do want you to recall is from the past few lessons, we've been focusing on the slope y-intercept form of a line, which is our y equals ax plus b formula. The one that we are going to be learning now is called the standard form. This is written as a, notice that it's a capital A, not a lowercase a, x plus b, again, capital B, not lowercase b, y plus c equals 0. And this is where a is a positive integer. It cannot be a negative number. So whenever you write it, it cannot be negative. It cannot be a fraction. Just going to note that down. If you get a negative number or a fraction, you are going to have to multiply the whole equation through to get rid of that negative or that fraction. B and C are just integers. Again, whole numbers only, doesn't matter if they're negative or positive. And A and B cannot both equal 0. They have to be there in some way or form. So when we take a look at this, remember that from the slope y-intercept form of an equation, we can gather our y-intercept and slope. That's what it tells us. What I want you to think a little bit about is what information can you determine by looking at the standard form of a linear relation. We are going to start discussing that today, so we're not going to write anything down there yet, but I want you to take a moment to try and think about what that might be, knowing what that looks like. So when we go on to some examples, the first thing that we're going to do is rearrange standard forms of the equation into the slope y-intercept form. There is a way to graph the standard form of an equation. It's a little bit more mathematical based, so sometimes people prefer to rearrange the equation into our slope y-intercept form so we can easily grab our slope and y-intercept. So the first step that we're going to do is we're going to move everything not attached to y to the other side, and then we are going to divide by the coefficient of y, because remember, we want it in y equals ax plus b. So I want to isolate y on its own. So first thing that we're going to do, I'm going to move this over and it becomes negative 4x. I'm going to move this over and it becomes positive 3. So I will get y is equal to minus 4x plus 3, and I'm done. Now we have it in ax plus b format, so we know that negative 4 is our slope, and we know that positive 3 is our y-intercept. Just going to erase that. Awesome. And now if we move on to the second example for b, I'm going to do the same thing. I want to bring my 2x and my positive 9 over. So I'm going to bring this over to become negative 2x. I'm going to bring this over to become negative 9, and I will get 3y is equal to negative 2x minus 9. Now this one has the additional step of I have a coefficient in front of y and I want to get rid of that. So remember, to get rid of it, we're going to divide that side by 3. Whatever I do to one side, I must do to the other. So I'm going to do negative 2 over 3, and I cannot forget to do negative 9 over 3 as well. So this will end up being y is equal to negative 2 over 3x. This is a common mistake I noticed on the test, so I do want to point it out. If you see something like this, remember you can reduce that to lowest form. 9 is divisible by 3, so that becomes negative 3. And now I have my final equation. Negative 2 over 3 is my slope. So that means it has a rise of negative 2 and a run of 3, and my y-intercept is negative 3. If I come up to C, I have 4x minus 2y minus 4. So again, I'm going to bring everything that is not y over. I will get negative 4x plus 4. So I will get negative 2y equals negative 4x plus 4. I now want to divide everything by negative 2 to get rid of that. Negative 2, negative 2, and I will get y is equal to, remember, negative 4 divided by negative 2 is just going to give me positive 2x. Now here is where the difference is. I have negative and a negative divided by a negative gives me a positive. Here I have a positive divided by a negative, so that will be negative 2. Awesome. And last example for this, I'm going to bring my x over and get negative x. I'm just going to change the color. And I will get negative 5, which means I will get negative 4y equals negative x minus 5. I'm going to divide both sides by negative 4. And I will get y is equal to 1 over 4. Remember, negative and a negative becomes positive. Negative and a negative becomes positive. So I get 1/4 x, or x over 4, however you want to write it, plus 5 over 4. Which means my y-intercept is 5/4. And my slope is 1 over 4. So I have a rise of 1 and a run of 4. Awesome. Now we are just going to move on, and we are going to do a little bit of math using our slope y-intercept form. So when using, or sorry, not using our slope y-intercept form. When using our slope y-intercept form, we can determine the y-intercept just by looking at the equation and going which one is not connected to an x. If it's on its own and just a coefficient there or a constant that's there, we know that is our y-intercept value or our b value. What we don't know when looking at our standard form is what the y-intercept is, what the slope is, how can we actually graph that line? So we're going to talk about that right now. One thing that you do want to keep in mind, we have talked about this a little bit already. I'm just going to draw out my Cartesian plane. Let's draw it this way. So when we are talking about our y-intercept, so this is my line. Remember, my y-intercept is the point it crosses the y-axis. Similarly, my x-intercept is the point it crosses the x-axis. If I can determine those 2 points from my standard form of a line, I can determine how the line is going to go. Because say, for instance, I had this graph and I didn't have the line. Let me just move that line out of the way so you can see what I mean. What I can end up doing is now connecting these 2 lines. And now I have that line. And if I look over, again, this initial line wasn't actually drawn straight, but you can see I pretty much get the same exact line. One's just a little straighter than the other, but that's fine. So if you have the standard form of a line, the easiest way to figure out how to graph this is to figure out what the x and y intercept are. So one thing I do want to point out about our y-intercept, this is always the point that x is equal to 0. So this is when x is equal to 0. My x-intercept is when y is equal to 0. Because if I look right here, if I'm on my x-intercept, I'm at 0 on the y-axis every single time. If I look at my y-intercept, I'm at 0 on the x-axis every single time. So typically, we can use the fact that 0, comma, y is going to represent our y-intercept, and x comma 0 is going to represent our y-intercept. So when we solve for this, I can use the fact that I know that x is equal to 0 or y is equal to 0 at one of those 2 points so that I can isolate it down. So I'm going to start off by looking for the x-intercept of this line. To do this, we are going to set y to 0. So when I do this, I'm going to get 3x minus 0 plus 15 equals 0. Now I can solve for x, and that can tell me what this point is. Because I know when 0 is equal to y, my x value is my x-intercept. So if I solve this equation, I will get 3x plus 15 equals 0. I'm going to move my positive 15 and it becomes negative 15. So I'll get 3x minus 15. Divide both sides by 3 and I will get x. Sorry, don't like that. X is equal to negative 5. So I know that my x-intercept is negative 5, 0. If I solve for my y-intercept, I'm going to set x to equal 0. So again, using the same exact equation, I will get 3 times 0 minus y plus 15 is equal to 0. This goes away. because that's just equal to 0 and we don't need it in the equation. So I'll get minus y plus 15 is equal to 0. In this case, I'm just going to move the y over just to make it a positive y. So I will get 15 is equal to y. And that just means I don't have to do an additional step of multiplying by a negative number or dividing by a negative number to get rid of it. It just gives me a positive number to start off with. If you don't see it that way and you move the 15 over and make it negative, you can just divide or multiply by -1 to get rid of the negative. Just make sure that you do that step so you get the right answer. So that means that my y-intercept is 0, 15. Now, if I wanted to graph that line, I have my 2 points, and now I can graph it. Awesome. We're going to do another example of that, and then we are done for this lesson, which is going to be 6x plus 4y minus 12. So when I do this, again, I'm going to start off by looking for my x-intercept. I feel like I did not leave myself enough room here. So we're going to set y to equal 0, and I will get 6x plus 4, minus 12 equals 0. Simplify that down just to get 6x minus 12 equals 0. I'm going to move my 12 to the other side and it becomes a positive 12. So I will get 6x is equal to 12. Divide both sides by 6. And I will get x is equal to 2. Which means my x-intercept is 2, 0. And if I solve for my y-intercept, I'm going to set x is equal to 0. So I will get 6 times 0 plus 4y minus 12 equals 0. Just going to simplify that down to get 4y minus 12 equals 0. You could do this step and the next step I'm about to do in one step, whichever way you prefer it, as long as you show me your work. So that becomes positive 12 again. So I will get 4y is equal to positive 12. If I divide both sides by 4, that means I will get y is equal to 3. So my y-intercept is, 0, 3. Awesome. So that's everything for today's lesson.